All right, so so we're gonna start stats, right? And just like with matrices chapter, we first had like a preliminary from chapter 0. This one too has a preliminary from chapter 0, and it's 0.8. So we're starting from 0.8. All right, so we're gonna talk about statistics. Okay, and we throw this word around all the time. All right, stats, statistics. I'm gonna take stats. I'm gonna, let's look at the stats. What is statistics? Well, statistics is the science of collecting, analyzing, interpreting, and presenting data. Okay? So basically, anytime there's a survey, anytime there's a poll, anytime there's a study, anytime there's an experiment, right? You have data, like a basic run-of-the-mill experiment in a classroom, whether it's a chemistry lab, a physics lab. You have data, right? Biology lab, you've got data. And then what do you do with the data? Well, now you have to analyze it. How do you make all those numbers, 15.7, 13.2, 20.9, how do you make those numbers mean something, right? So statistics is a way of us interpreting that data so that we can look at it in a more meaningful way. Okay, like when you watch the news all the time, they throw around these numbers. Okay, 37% of blah blah blah, and then you have to go back and say, okay, is this really a valid number? Okay, 37% of whatever believes blah blah blah, and then you have to go, okay, who are these people that were surveyed? Is this the entire population? Is this just 22-year-olds that were being asked this question? How do you come up with the 37%? Is this a mean? Is this a whatever? What is your standard deviation? How meaningful is 37%? All of that is statistics, okay? All right. A lot of it is a way of interpreting and presenting information, okay? And figuring out when you have a whole bunch of values, data, what can you, like which part of the data can you take seriously? Which part of the data is just like stuff, numbers that you can just throw away? Okay, so let's talk about some vocabulary. First, we have a measure of central tendency. This is just something that represents the center or the middle of the data. Okay, that's important, right? Because whenever a teacher grades a test and we're going to pass it back, what's the first question students usually ask? What's the average, right? Where was the middle? That's measure of central tendency. So sometimes it's important to see what happens in the middle of the data. Okay, this is important. Population is the entire membership of objects, people, events, which is to be analyzed. Okay? A sample is a subset of the population. So for example, if you want to do a poll on what Americans think about blah, that, like, Americans is your population. Now, do you go and ask every single American that's alive today? That is just silly. What you do is you take a sample of people, all right? And here, like just in that word sample, you could spend months talking about what a sample should look like, right? It should have like the same diversity as America does, right? Like if you have 37%, from an ethnic population, then 37% of the people you survey has to have that ethnic, right, background. So that's a sample. Outliers are values that are extremely high or extremely low. So for example, if an average on a test was like an 83%, okay, and somebody scored 15%, okay, let's say all the scores on a test were from 70 to 100, and somebody scored a 15%, you can just take that 15% out of the equation. All right, that's an outlier. Okay, notation. Okay, so this symbol here, okay, looks like an E. It's actually the Greek letter sigma. Yeah, this is the Greek letter sigma. This is a capital sigma. So the Greek letters, like the Greek alphabet, right? You have alpha, beta, gamma, and so on. The letter that makes the s sound, we call it S. What do they call it in Hebrew? Okay. In Greek, it's called the sigma. So this is a capital sigma. And we'll get introduced to this later. That's a lowercase sigma. Okay, so that's the equivalent of a capital S and a lowercase s. So, a little bit of a pet peeve of mine. In Hollywood, often that letter, like that symbol, is used to represent an E because, as Max pointed out, it does look like our English E. So sometimes, like, they'll write, let's say, like, they'll say, like, Greek like this. It is such a pet peeve of mine because that's really like right. That's really like Gursisk, right? And I'm just like, okay, that's not E. That's Gursk. Stop doing that. No, that's sigma. Okay, so sigma in math, sigma s, right, means sum. Okay, because sum s, sigma s. Okay? X is usually the variable, for like individual data values. You know how we have like A1, A2, A3? Well, now we're going to have like X1, X2, X3. N is the number of data values. So if you talked to 23 people, N is 23. Capital N represents the number of data values in the population. Okay, so this is number of people you survey, okay, or you poll. This is the number of people in the country. You see the difference? Okay, all right. Mean, also called arithmetic mean. This is so this is a measure of center. There are several measures of center, and all measures of center means is how do you look at like what's in the middle, okay? This is obtained by adding values and dividing by the total number of values. What does that remind you of? If you add all of the numbers and then divide it by how many numbers you added. What's another word? The average. So the average that, when you ask me what was the average on the test, it's really mean, okay? We don't say average, we say mean. Most people, not math teachers, most people, though, refer to mean as the average, okay? All right. If the data is a sample from a population, the mean is denoted by this symbol, and we call it X bar. Okay? So for mean, I say X bar. All right? Here's how we write the terminology, the formula for it. So X bar, meaning mean, equals the sum of all the data values divided by n. Okay, so you see the notation? The sum of all the data values divided by n. If the data is the entire population, so like you do a census and you have the age of every single American alive, okay, and you take the average of all those people, then we don't say X bar, we have this other Greek letter, mu. That's a mu. That makes the m sound. Huh?
I was just asking, it kind of looks kind of like what you do for the
right. Yeah. It's a totally different letter. And then mu is, again, the sum of all the values divided by capital N. That's everybody in the population. I know. Okay? All right. So here, let's find the mean of the following set of numbers. So here, I'm going to add all these up. So first of all, how many are there? 1, 2, 3, 4, 5, 6, 7, 8. Right? There are 8 of them, so n equals 8. Okay? And x bar is the mean. So we're going to do 14 plus 7 plus 5 plus 23, 9, 1, 5, 19 over 8. A piece of advice. If you're plugging this into your calculator, what do you also have to include? Parentheses, right, around this whole thing. So x bar is 10.4. Okay, so that's the average. If these were, let's say, scores, right, quiz scores out of 20, this is it. Okay? All right. Why is mean such a cool thing to find? Okay? What are some advantages of mean? Okay. So first of all, it's relatively reliable. The means of samples drawn from the same population don't vary as much as other measures of center. Okay. You will learn that there are other, when I look at your test scores, one of the things I look at is the average, the mean. Another thing I look at is the median. Another thing I look at is standard deviation, or other things like that. Mean, the good thing about mean is it doesn't vary as much. So for example, if I added one more data point, the mean is going to stay pretty consistent. If I took out a couple of data points, it's going to stay consistent. You see what I mean? Mm-hmm. Okay. And one good thing about the mean is it takes every data into account. Okay? Every data point. Okay. Disadvantages of mean is that it is sensitive to every data value. See, so yes, it's good that every data point is being taken into account, but the thing is, like, every single score could affect it. So for example, if I have test scores, which are, let's say, 71, 77, 83, 91, and 94, right? And then if I have another one who scored 11, okay, that 11, that one person is going to bring the average way down, whereas like most of the population, well, that's the thing, is if you're taking the mean, you must count them all. So a disadvantage of using the mean to analyze your data is that one outlier will bring the average way down. Okay? So one extreme value can affect it dramatically, and it is not a resistant measure of center. I'll talk about what resistant measure of center is. Okay? Later. All right, so that's mean. One other thing is median. Median is physically the middle value when the data values are arranged in order of increasing or decreasing magnitude. So if I get the scores and if I put them in order, okay, how many scores were here? 1, 2, 3, 4, 5, 6. Let's add one more, a 97. Okay, what's the data point exactly in the middle? It's this one, right? So it's physically the one in the middle. It has nothing to do with its value. It's just that it's placed in the middle.
And what if there is no middle?
Then you take the middle, the average of the middle. We'll talk about it. Yeah. The median is often denoted by this, not x bar, x tilde. It's that. So that's the button on your keyboard, far right, far left top corner, the one that nobody ever uses. Okay, like to the left. No, not on that, on your QWERTY keyboard. Like that's to the.
Oh, like the actual keyboard?
Like an actual computer keyboard. That's that one that nobody ever uses. Okay. All right, but.
What is it even used for?
Well, it's for median x tilde.
But you can't put it on offset.
You can if you have a special math font feature program.
Yeah. Come on. I don't know.
It's also used for like similar triangles.
Yeah.
Okay.
Or
Artsy people use it a lot because it's cute. I use it for math.
like I do it for like
Yes.
bullet points.
Right. I do it for math. Okay.
I do it for Spanish words.
So to find the median, it's important to sort the values, right? Increasing to decreasing, because if you just find the middle, then it's just some random data point. Okay? So if the number of data values is odd, the median is located in the exact middle. But as Gabby just pointed out, if the number of data values is even, then the median is found by computing the average of the two middle numbers. Okay? Now you do.
So you would add those two together and then divide by 2.
Correct. So let's take a look at this. How many is in here? 1, 2, 3. Oh, we can't even do that. First we have to sort it, right? So let's sort this. 1, 5. Okay, so here's how I do this, by the way. Every time I use 1, I cross it out. 5, 7, 9, 14, 19, 23. Okay? And then, so 1, 2, 3, 4, 5, 6, 7, 8. Right? 8 of them in here. So if you go to the middle, these are the middle two. Okay? So x tilde is 7 plus 9 over 2, 8. That's the median. What does that mean? What does that mean? The middle value is here. So suppose these were scores on a quiz. Okay? This is the middle number. Now what I just did is I cut the scores into 2. I cut the list of students into 2. If 8 is the middle number, that tells me that half of the students scored above an 8 and half scored below an 8. And that's very useful information sometimes, right? When I look at your scores and the median is, let's say, an 82, I say, oh, half the students scored above an 82, which is pretty good. Okay? Another thing I look at is, okay, what was the average? The average was an 84. What was the mean? 83. Okay, so the average was an 84, and half the students scored above an 83. Like, when those two match, that's a good thing. Okay?
So that is for how you find it.
That's it. That's it. That's just the median.
You don't want to.
I do. I do. Okay, so here, let's do this one. We're going to sort them again. So it's going to be 18, 20, 25, 26, and 38. And what's the median here? 25 is the median.
Do you not have that equals 5?
Equals 5?
Because there's 5.
I don't have to. That's just for me.
Okay. Yeah, that's what I was thinking.
Right. Okay, so we did mean, median. Now let's do mode. Mode is the value that occurs with the greatest frequency. That means it's the value, it's the scores, it's the score that you have more of. So for example, if like 2 people got a 27, okay, and everybody else and each of the scores happen one time, then 27 is your mode. Okay. Data can have more than one, or no mode. So if everybody, if there are 10 people in a class and everybody got a different score, no repeating scores, no mode. Okay. Bimodal, what's a bicycle? How many wheels? 2. Bimodals, 2 data values occur with the same greatest frequency. Okay? Multimodal or multimodal, more than 2 data values occur with the same greatest. No mode, no data value is repeated. I know. The next time you say this at a math party, I tell you, you're going to be right in. You're part of the cool crew.
The first one is just
Okay, let's just do this one, right? Find the mode of each of the following data sets. So you basically want to look at values that repeat. You want to see, are there any values that repeat?
Yeah, 1.10.
1. So 1.1 and 1.1, there's 2 of that, right? None of the other ones repeat, so the mode,
Bimodal.
no.
No.
The mode is 1.10. There is just one number that repeats.
Oh, I
see,
see.
okay.
So the mode equals 1.10.
So this would be a multimodal.
Okay, so let's see here. So we have 27, 27, 27. 55, 55, 55. 3 of those. Okay, 88, 88. That only repeats twice. Out. That's out. Okay? So, yeah. So the mode
It's a bimodal.
is 27 and 55. So first it's important to say what the modes are. And yes, this one has 2 modes. Please, please, please remember that this is the value that occurs with the grade test frequency. Okay, so these are the ones that occur most often. Okay, correct. All right, and the modes are 27 and 55. Okay, here 1, 2, 3, 6, 7, 8, 9, 10. No mode.
You have to write like it's bimodal.
If I ask you, okay, and it's important to keep that in mind because later when we're looking at like charts, graphs, histograms, whatever, this stuff will come back. Okay, like there will be like a set of data points that are grouped together, they're, whatever. Okay? Okay. So these were just measures of, these were like the very basics. These are a lot of times things that when I used to teach this in algebra too. So, these are just the very basics of the trends in a data set. Yes. Okay. Measures of variation. Okay, now here's another important piece of information. More than what the average is on a test, sometimes, we want to know how big is the variation. So for example, like if all the scores are like, clumped together between like, an 85 and a 95, okay, that says one thing. But then if I have, 40s, 50s, and 95s and 100s, and stuff in the middle, then it's spread over a larger interval, you know what I mean? A larger area. So when we look at those, these are called measures of variation. Okay, so now there are a couple of things we can look at. One thing we can look at to see how spread out the data is, okay, so it's how spread out data is. One thing we can look at is range. The range is just highest value minus lowest value. So it's the difference between the maximum data value and the minimum data value. So you literally just do high minus low. Okay? The thing with this is it's very sensitive to extreme values. So for example, if I'll come back to here, but if in this example of these test scores, if everybody got like between a 71 and a 97, and this guy just got an 11 because he didn't get like, the last thing, somebody just gave him only the first page of the test or whatever, right? And he just scored an 11, okay? It's going to mess everything up because if you do the range, now all of a sudden it's going to have like a spread of 86, whereas here they would have had a spread of 26. You see that? So that's the bad thing about range. It's very sensitive to the extreme values. So it's not very useful. Okay, so here are some test scores for a particular chapter of algebra. Find the range. So we want the maximum here is a 97. And the minimum is a what? 70. Right, so the range, right, so that's 27. Okay, and it's as simple as that. Okay, now for the biggie. This is the one. This is the one we all like. Okay? Standard deviation. This is the one that we like. This is a measure of how much values differ from the mean. Okay, let's talk about this for a minute. Suppose I give a class a test, and then I find the average. Okay? Now, I go, okay, the averages I guess were okay. The average was okay. And then I ask myself, if I pick a random student, okay, how far was his or her score from the average? And then if I take another student, how far was his score from the average? So the thing is, once you find the average, then you ask yourself, was everybody's score close to the average? Or is it like totally spread out? Okay, because think about it, if everybody's score is close to the average, then you can pretty much assume that everybody has like the same amount of understanding, right? So like it implies a lot of different things. So the standard deviation is how much do individual scores vary from the average, okay? And then you lump them together, okay? And you don't even have to you don't have to use it just for like averages. So for example, if the average height in the US is like, I don't know, 5'4", right? Then you say, then like you take a specific person and you're like, okay, how close is this person to the average height? You know what I mean? Well, they're within 1 or 2 standard deviations. And then if you take somebody who's like, I don't know, 7 feet, okay, they're really far from the standard, from the average. Okay. So standard deviation is denoted by lowercase sigma. Okay, remember I told you we're going to use it soon? Well, here it is. It's now. So it is an average deviation of values from the mean that is calculated using this formula. Okay. What is this formula? Okay. It seems overwhelming, right? Okay, but we now know what all of these numbers look like. I mean, what all of these symbols mean. Okay, so look. The first is a square root. Okay, big deal. We've been doing square roots since we were like yay high. Okay, that's cool. Now, the bottom here is n minus 1. What was n?
The side,
Right,
like
how many numbers there are? Minus 1. Okay, we can do that. That's cool. That's easy. What's x? X is each number.
Oh.
What's x bar? What's x bar?
X bar is the
mean. Okay, so you take. Listen. You take a value minus the mean. We can do that, right? And then you square it. You can do that too, right? Yes?
Yes.
Okay, then you take a second number minus the mean and you square it. Third number minus the mean and you square it. Fourth number minus the mean and you square it. All of the numbers minus the mean and you square it. And then it says sigma. So all those numbers that you just got, you add them up, right? So you add them up. We're going to do one like ad nauseum. You add them up, divided by n minus 1, which is just another number. Take a square root and bam, you're done. You just found the standard deviation.
Wait, so then you add all values?
Yeah, look, we're going to do one here, okay? Before we do that, though, let's look at some important properties of standard deviation. Okay? The standard deviation is a measure of variation of all values from the mean. Okay? Standard deviation is usually positive. Okay? So suppose I give you a test and everybody gets a 93. What's the average? 93. So how far is a specific student's score from the average? 0. So in that case, the standard deviation is 0. Okay? So standard deviation is 0 when all of the data values are the same number. Okay? Everyone has same score. Never negative. Larger values of sigma indicate greater amounts of variation. So if the sigma is large, it means, yeah, the average may have been a 70, but people got like 100 and a 2 and a 97 and a 3, okay? Okay. Here's another one. The value of the standard deviation can increase dramatically with the inclusion of outliers. Okay. And then the units of standard deviation are the same as the original data values. So if we're talking about, let's say, height in feet, you know, right, the standard deviation is like 4 feet. Okay, let's do this. Let's do this. Okay. Yikes is right. Okay, so here's my sample values. First, we need the mean. So let's do the mean. Yeah, and for the mean, we don't need it to be in order. Plus 14. So this is x bar over how many? 5. So the mean is actually, oh, you know what? I was going to do that here. 2 plus 8 plus 10 plus 12 plus 14 over 5. This is 46 over 5. So x bar is 9.2.
Oh, that's it.
Okay. Now, here it says x minus x bar. Okay. So we're going to subtract the mean from each individual value. So I'm going to do 2 minus 9.2, 7.2, negative. 8 minus 9.2, negative 1.2. 10 minus 9.2, positive 0.8. 12 minus 9.2, 2.8. 14 minus 9.2, 4.8. Okay, let's go back to the formula. I just did x minus x bar. What's the next step? What's the next step in that formula? Here, look. X minus x bar, I just did that. Now I gotta square each of these terms. Okay? So now, square each of the deviations. Okay? So, when I square a negative, what do I get? Right, so I don't even include the negatives here, right? I do 7.2 squared, 1.2 squared, 0.8 squared, 2.8 squared, 4.8 squared. So I get 51.84, 1.44, 0.64, 7.84, 23.04. Yes. So, going back to my formula, I did x minus x bar, then I squared, and then what's next? Sigma. Sigma means sum, right? So now I'm going to add all of them up.
Oh, add all of the, like, 7.
Yeah. So now I'm going to add all of those up here. Okay? So I'll get 51.84 plus 1.44 plus 0.64, 7.84, 23.04, and I get a whopping 84.8. Okay? So, I did the sigma here in blue. What's after the sigma? You divide by n.1. Divide by n.1. So n in this case was 5. So n minus 1 is 4. That means here I do 84.8 over 5 minus 1, 84.8 over 4, 21.2. And when you take that, when you divide it, what's the final thing? Square root. It's not that hard at all. 4.6. So the standard deviation is 4.6. That means, okay, on average, each value is going to be 4.6 units away from the average, from the mean. Okay. All right. So let's do that here. Sample values, standard deviation. All right, so we're going to do the same thing. So first it's, what's x bar? X bar, 5 and 9 and 6, 3 and 7, how many? 1, 2, 3 over 5, 6. Right, and x bar is 6. So now, x minus x bar is going to be 5 minus 6, 9 minus 6, 6 minus 6, 3 minus 6, 7 minus 6 is 4. Next step is x minus x bar squared. Oh, it's 1. Okay. Then it's going to be x minus x bar squared. So whatever I got over there, I'm just going to square them, right? So that's 1, 9, 0, 9, and 1. You see that? Like, minimize the writing. Then I add them all up. 1 plus 9 plus 0, 9 plus 1, I get 20. Then I do that over n minus 1, so that's 20 over 5 minus 1, so that's 5. Okay? No?
Yes, sorry.
And then finally, I take a square root of all of that mess. 5 over, no, 20 over.
Sorry. Yes.
No, no, square root. Square root of 5, 2.2.
How did you get square? No, isn't 20? It's 20 over
So when I divided, I got that, 5. And now I take a square root of all that.
How? Because 20 divided by 4
Is 5.
Yes.
So finally, I say sigma is equal to 2.2. Okay, so I'm going to give you about like 5 minutes to do this one.
Wait.
So x bar is all of these numbers added together. Okay, so I get 5.05. And n equals 6. So look. Okay, can I tell you something? Another shortcut. X minus x bar right? And then I'm going to square it, right? I don't even do negatives. Do you know, like, because it's pointless. So I do like 2.3 minus 5.05. And yeah, that's negative something, but I just write positive 2.75, right? And then the next number gives me 0.35. The next one gives me 3.45, 2.15, 4.45, 0.05. Then I'm going to square these, right? So do you see how like I make it short for myself, less writing? 7.5625, 0.1225, 11.9025, 4.6225, 18.8025, 0.0025. What comes next for sigma? I'm going to add these up, divide by 5, and take a square root. Okay, so let's just go on the calculator and see how I'm going to do that. Okay, so yeah, so on the calculator, look at what I'm going to do. I'm going to add them up. Point 1.225, 11.4.6, 18 point plus 0.0025. I added them up. Now I divide by 5. And then I take a square root. So I get 2.933, which is approximately 3. Okay, calculator time. Okay, let's do graphing calculator stuff. You can do this exact same thing on a graphing calculator. All right, let's do it quickly. So what we do is click this one, stats. No, stat. So it's right under the delete button. Hit number 1 for edit. Type in the data values. I don't know where those came from, but we're going to type in the data values there. So we're going to do 2.3. Yeah. 4.7. 7.2. 9.4. 5.1. Oops, 5.1. And I need to clear these. I don't know where they came from. Okay, so here we go. Okay, go back to the home screen. So second quit, right? This is the home screen. Now we're going to do second stat. Okay? It's just like the matrix. And then we're going to go to the right to the math tab. And we want standard deviation. That's number 7. You see that? So hit 7. Now, what do you want the standard deviation of? Again, second stat. Okay? And, wait, second stat. And we want L1. Same answer. Fantabulous. Okay? So, second and mode. Second mode. So second and the one right next to it. So, yeah. So here we have this that's going to be due not Tuesday but Wednesday. Right. So for you guys, for D period, it's going to be Wednesday, 4:25. Okay?